Today I will solve a few problems on signal flow graph. This is basically the application of Mason's gain formula, which helps us to identify the relation between output and input of a given system. The Mason's gain formula can be written as the transfer function of any system is given by summation of pi delta I divided by delta, where pi is the path gain and delta I is the uh, is 1 minus summation of pm pi, where pi is the gain of a non-touching loop for that path. Okay, so this is the numerator of the system transfer function. The denominator is given by delta is equal to 1 minus summation of pm1 plus summation of pm2 minus summation of pm3, where pm1 is nothing but the gain of any individual loop. So you have to take the summation of all individual loop gain. pm2 is the product of two combination of two non-touching loops. So if you have two or more non-touching loops in the system, then you have to take all possible combinations of non-touching loops. Similarly, PM3 is the product of loop gain of three non-touching loop and all combinations. Okay, sounds a bit complicated, but we'll try. We'll do a practice on this thing. Okay, so now this is a given system, and we have to identify. The first and foremost work is to identify the number of loops and number of forward path gain. So if you see, we have a forward path is traveling from y1 through y2, y3, y4, y5, y6. And if you write the gain of p1, this is a12 multiplied by a13, a34, a45, a56. Okay. We have another path which is going from y1 through y2, y3 and y5. So this is the path. Okay, so if I take the gain of path 2, this is a12, a23, a35, a56. We do not have any other forward path. Now we have to identify the loops. If I just try to find out the loops over here, you can see we have a loop starting from w2 through starting from y2 through y3, y4 and coming back to y2. This is loop 1, and the loop 1 gain can be written as a23, a34 into a42. Coming to loop 2, it starts from y3 through y4, y5 and y3. Okay, so this is L2. A34, A45 and A53, and the third loop is L3, which is starting from Y3 going directly to Y5 and coming back. So this is another loop. This is L3, which is A35 and A53. Now we do not have any loop in this system which is not touching P1 or P2. All this L1, L2 and L3 are touching both P1 and P2 because they have a common node. So numerator is nothing but the sum of P1 and P2, and denominator also does not have any the system does not have any non-touching loops. You can see L1 is touching with L2, L1 is touching with L3 because they are sharing Y3 is common to all the loops. So the transfer function becomes simpler. Uh, in this case, transfer function is simply given by summation of Pi divided by 1 minus summation of P1 because I do not have P2, P3 tau. So this is nothing but P1 gain plus P2 divided by 1 minus L1 plus L2 plus L3, which is um, nothing but right, A122356. We can write simplified from 1 2 2 3 A56. We can take this thing and then A34 plus A45. Sorry, this is multiplication plus A35. This is the numerator and denominator is 1 by L1 is 233442, A233442 plus A3445 A53 plus A35 A53. So this is the transfer function for the given system. All right, we'll go to the next problem. Next problem, we have to find out the transfer function between C and R. So we'll follow the same process. Let us find out the forward path. It starts from R going through this thing. So this has only one forward path, and that is given by P1. Loop gain is nothing but G1, G2, G3, G4. Okay. Now let us see how many loops are there. We have one loop over here. We have another loop over here. We have another loop over here, which is L3, and we have one more which is starting from here going all the way till this coming back, which is L4. So now let us write the loop gain for each of them. So L1 gain is nothing but -1. L2 gain is -1, so G4 minus G4. Okay, L3 is G3 G minus G3 G4, and L4 is minus G2 G3 G4. Okay, we have to find out the transfer function. So we can, if I write the transfer function, numerator is pretty simple over here because we have only one forward path and there is no loop in the system which is not touching P1. So the numerator is pretty simple. Now we'll come to the denominator. Denominator will see 1 minus L1 plus L2 plus L3 plus L4, sum of all loop gains, plus we have to take the combination of two non-touching loops. So if you see, L1 is not touching with L2, L1 is not touching with L3, and rest of the things all are touching to each other. Okay, so what the second term will be L1 into L2 plus L1 into L3. Since L1 and L4 both are touching each other, we cannot take that as well. So now we'll replace P1, I mean the loop gain and path gain. This is nothing but G1, G2, G3, G4 divided by 1 minus, so since all of them are negative, 1 plus 1 plus G4 plus G3, G4 plus G2, G3, G4. Okay. Next term is L1, L2. So it's again G4 and L1, L3 is G3, G4. G3, G4. So if you simplify them, it can come like this. Transfer function is equal to G1 plus G2 cross G3, G4 divided by 2 into 1 plus G4 plus G3, G4 plus G2, G3, G4. This is the final transfer function of the given system.